This is section 3.3, part B. We'll now turn to looking at adding and subtracting of algebraic fractions. And again, I want to start by reminding you about what you already know about numerical fractions. If you want to add or subtract two numerical fractions and you already have a common denominator, all you do is subtract the numerators and keep the denominator the same. 7 minus 4 gave me the 3, and I kept that common denominator of 9. Of course, I would reduce my final answer to 1/3. We can use exactly the same technique for algebraic fractions. If I already have a common denominator, then I'm just going to add or subtract the numerators. In this case, I am subtracting, and I would just urge you to be cautious with that. Subtraction really means the minus or subtraction or negative gets distributed to both terms. So in fact, if I were to kind of write this out before I combine the like terms, I would have the 3x plus 1, and then I would have a minus 2x and a minus 3 over my common denominator. Combining like terms is going to give me x minus 2 over the LCD. And then over here, notice that I did reduce my final answer. That's sometimes possible with algebraic fractions as well, not always, but sometimes. And in this case, I probably should check the factoring of the denominator to see whether I do get any reduction that I could do. This trinomial has an a of 1, so I know the x squared came from x times x. And then a sum of negative 6, product of 8. That looks like negative 2, negative 4. So I do indeed have the ability to reduce here. This x minus 2 on the top can be divided by the x minus 2 on the bottom. When I divide them, I just get a 1. And so my lowest term's answer here is 1 over x minus 4. All right, let's turn to the question of how we handle denominators that aren't the same. If I do want to add or subtract fractions, of course, I must get a common denominator. I'm not allowed to combine them until the denominators are the same. So in a problem like this with numerical fractions, I would look at the 6 and the 4 and say, well, I believe the common denominator here would be 12. And then I would create that common denominator of 12 in both fractions. In this case, I would have to multiply by 2 to get 12. I'm going to show that I'm really multiplying by a form of 1, 2 over 2. Again, I can't change the value of my expressions. I can only change what they look like. Multiplying by a form of 1, in this case 2 over 2, really keeps the 5/6 at the same value. It looks like 10/12 now, though. And the same idea here. If I want to get a common denominator, I would have to multiply by 3. So I'll actually multiply by 3 over 3. Once again, a form of 1. So my 3/4 now looks like 9/12. Now that I have the common denominator, just like in the first example, we'll go ahead and add the numerators in this case and keep that common denominator. By the way, in algebra, we very, very rarely use mixed numbers. Improper fractions are preferred, so I would always leave that as 19/12 and not change it into a mixed number form. Let's try this now with an algebraic fraction. My first fraction that I'm trying to add is 2 over 5 x to the 4th y. And I'm adding 4 over 3xy squared. Let's begin by identifying the common denominator that we're going to go for. The 5 and the 3 would have a common denominator of 15. And then with the variables, I'll simply use the highest power of each one. So x would be to the 4th power, y to the 2nd. If I compare the denominator I already have to what I want, I can see I would have to multiply the 5 by 3. X to the 4th is fine, but I need to multiply by another y. I have to multiply by a form of 1, so 3y over 3y. That makes my first fraction 6y over 15 x to the 4th y squared. Turning to the second fraction, to get to this common denominator, I'd have to go 3 times 5. X's, looks like I would have to multiply by an x cubed. And the y's are fine, just the way they are. So I'll multiply by 5x cubed on both the top and the bottom, form of 1. And my fraction now becomes 20x to the 3rd over 15 x to the 4th y squared. I've got the common denominator, meaning I can now combine into one fraction. And in this case, when I add, those aren't like terms. So the best I can do is just sort of bring them together into the same numerator and keep the common denominator. In this case, I don't believe that there's anything that could be reduced. All I could factor out of that numerator would be a 2. And 2 is not going to reduce with a 15. So I'm going to leave this the way it is, since it's not going to reduce anyway. All right, we'll continue to do some more adding and subtracting, coming up with common denominators. But really the key to working with fractions like this is always to remember that whatever you do, make sure that you're multiplying by a form of 1 to change the form of your fractions. That way you're never changing their value. Okay. A little outline of the process then of adding or subtracting fractions if we're not given a common denominator. Make sure everything we have is in factored form, and from there determine the common denominator. As we were doing, multiply each factor by the appropriate form of 1 to create that common denominator in each fraction, and then add or subtract the numerators, keeping your common denominator. Finally, reduce to lowest terms if possible. So in number 3, I have 2 individual linear denominators. There's nothing that I could multiply either one of them by to get the other. So my common denominator is actually just going to be the product of both. X plus 3 times x minus 5. Going to my first fraction and comparing what I have to the LCD, I'm missing the x minus 5. So I'll multiply by the form of 1, x minus 5 over x minus 5, giving me 6x minus 30 over the common denominator x plus 3, x minus 5. All right, the second fraction. 2 over x minus 5. And again, I'm going to compare that to my common denominator, and notice that what's missing is the x plus 3. So I'll multiply by the form of 1, x plus 3 over x plus 3. And that's going to give me 2x plus 6 over that common denominator. Now that the denominators are the same, I can go ahead and add the numerators. So I'm going to get 8x minus 24 over the LCD. I will comment that I could factor an 8 out of the numerator, and in fact, let me just do that to show you what I mean here. But even if I did, there's no factors that I could divide out to 1. These are tempting, but they're not the same, right? One's got a positive, one's got a negative. They're not just reversed. They're truly different factors. So this is done. I can leave it in its completely factored form, or I can go back to this form. I would never multiply out the denominator, however, in a final answer. So either of these last two is fine. Since nothing reduced, I probably would leave it like that. Example 4, there is some factoring I can do in those two denominators, so I'd like to do that first. First fraction, if I took an x out, I would have x minus 2. And second fraction looks like a trinomial with a equal 1. So x squared is x times x. And a sum of negative 5, product of 6, thinking negative 2, negative 3. All right, now that I look at the factored forms, I can better identify my common denominator. I'm definitely going to need the first one, x times x minus 2. And then when I look at the second fraction, it has a factor of x minus 2, but that's already in the common denominator, so I don't need to put another one in. The x minus 3, though, isn't here yet, so I do need that one. Now all the factors in both denominators are represented in my LCD. So let's get the LCD for both fractions. In the first one, we're missing the x minus 3. So I'm going to multiply by x minus 3 over x minus 3, form of 1. And that's going to give me 4x minus 12 over x, x minus 2, x minus 3. Subtract. Second fraction was 1 over x minus 2, x minus 3. And comparing that to the common denominator, the only thing we're missing is the x. So I'll multiply by x over x. So common denominator, meaning I can combine the terms in the numerator. 4x minus 1x would give me 3x minus 12 over the LCD. Just double checking, if I did factor the 3 out of there, I would get x minus 4, and I wouldn't be able to reduce anything. So I'm just going to go ahead and leave it like this. Couple more here. Example 5. Once again, I start with denominators that are not factored, so let's factor them first. This trinomial, x squared would be x times x, sum of -2, product of 1. It's going to be -1, -1. I'll leave myself a little space to get the LCD here. Minus 4 over. And this one, if I first take out a 3, I would have x squared minus 1. But then I could factor the x squared minus 1 using a difference of squares. So I'm going to have the 3, and that will become x plus 1, x minus 1. So for the LCD, I'm going to need 2 factors of x minus 1. I do need both of them because they both occur in the same denominator. You can write it as x minus 1 squared, of course, if you like. I'm just going to leave it written out for now. Coming over here, I need the 3. I'm just going to put that out front. I need the x plus 1. But I already have an x minus 1, so I don't need to repeat that. Okay. Again, the only reason I had 2 of them is because there were 2 in the same fraction here. So looking at this and comparing to my LCD, I'm missing 3 x plus 1. Let's see, there's a little bit of multiplying out to do up here. For right now, let me write that as x minus 2 times 3x plus 3. And I'm going to need another step to finish multiplying that. Minus, comparing this one to the LCD, we're only missing one of the x minus 1s. So I'll multiply by the form of 1, x minus 1 over x minus 1. And let's see, that's going to be 4x minus 4 over the LCD. I'm going to finish multiplying out up here, just FOIL. 3x squared plus 3x minus 6x minus 6. And I'm going to combine all this now into one fraction. Make sure that as you do this, since you're subtracting, that subtraction applies to both terms. So it will actually be a minus 4x, but a plus 4. All right, a lot of work to get to our LCD this time, but we're just about there now. Combining like terms in the numerator, I have 3x squared. Let's see, negative 3, negative 7x, and plus 4. And I'm going to go ahead and just write this as a shortcut, x minus 1 squared, x plus 1. One last thing I should check on this one, that numerator might be factorable, so I need to check and see whether I can reduce that fraction at all. And I'm actually running a little bit short on space here. I think I'll borrow a little space from another sheet of paper to do the factoring on so that I don't run out of room. If I take my 3x squared minus 7x plus 4 and look for numbers that sum to negative 7 but have a product of 12, I'm going to get negative 3, negative 4. So I have 3x squared minus 3x minus 4x plus 4. I could factor out a 3x and get x minus 1, and then factor out a negative 4, and also get x minus 1. So I have x minus 1 times 3x minus 4. And this time it looks like that was worth doing. I am going to get some reducing. So let's replace the numerator with its factored form. And then to finish this problem, I will have to say this x minus 1 and one of these. There's really two of them here, right? But I could divide out this x minus 1 with one of those, which is going to give me a times 1. And so my reduced answer will be 3x minus 4 over 3 x minus 1, x plus 1. All right, I'll remove my off-to-the-side factoring here. And we have one more add-subtract example. In number 6, if I start again by getting factored forms, hopefully that's becoming almost second nature to you. When we work with algebraic fractions, we really have to start out by getting factored forms. So I did the difference of squares in the first denominator. And in the second denominator, I'm going to factor out a w, giving me 5 minus w. Now, before I actually identify my LCD, I'd like to concentrate for a moment on these two very similar factors in the two denominators. We've seen this kind of thing before. In fact, what we know is that one of these is just negative 1 times the other. So rather than use them both as my common denominator, I'm going to choose instead to start by multiplying the second fraction by negative 1 over negative 1. That means I'll have a negative 2w on the top of the first fraction. And down here, I'm going to choose to leave the w the way it is and distribute the negative 1 instead into the parentheses. Okay. That w will then become positive, and that will become a minus 5. And I just changed the order as I wrote it down. This is really nice because now I have a simpler LCD. I don't have to use separate factors for those two. Instead, what I've got is w plus 5, w minus 5. It's my first fraction. And in the second fraction, I'm going to get a w, but the w minus 5 is already there, so I don't need anything else new. All right, let's create that LCD in our two fractions. First denominator is only missing the W when I compare it to the LCD. So my numerator becomes W squared plus W over the LCD. Plus, here I've got a negative 2W over W times W minus 5. And when I compare this one to my LCD, I'm missing the W plus 5. So let's multiply by the form of 1, W plus 5 over W plus 5. It's going to give me negative 2W squared, and then a minus 10W over that LCD. All right, now that I've got the common denominator, I can combine my like terms on top. I would have a negative W squared and a negative 9W. Over the LCD. And finally, I could factor out a W here, leaving me minus W minus 9. And then I will be able to reduce my final answer. W divided by W is just 1. So I could give the final answer as minus W minus 9 over W plus 5, W minus 5. All right, let's pause there, and we'll finish the section in the next video.